Hello, my people. Have I got good news for you? This is it. This is it for notes. Physical science. Hopefully it is almost in the books for you, all right? Kind of just changing my mind on all kinds of stuff, but also if you want to have a moment of celebration, gizmos are complete for this year, all right? No more of those. Miss Cheney will throw a few at you next year, but that's after the summer, so no need to think of such things, right? What I want to do, just one last thing here in the space unit before we start getting into exam review tomorrow. Okay, actually a little bit today, but mainly tomorrow. And then third hour, I know that you have an exam Wednesday. I will sneak in the school for that. I know this is on video, so I should not say such things, but there is a great chance that I will be there for that third hour exam on Wednesday, but that's it. And then I will be back for the half days Thursday, Friday, all right? But today's stuff, I feel like this is just one of those kind of cool things to think about. And whether you believe it, don't believe it, again, your call. But I think it's something that you should at least be curious enough and think critically about, because you should care about the stuff that makes you, all right? And so our goal here is to explain how the Big Bang explosion and stars create the elements essential to life. I don't know, I think it might have been early last week, we said, what do you think about the idea that we are made of star stuff? And it's pretty crazy to think about, but then we watched the video and you may or may not have caught on to some things. So there's going to be a couple times you pause me here, and you're probably starting to enjoy that, just shutting me up. But the first thing I want you to do, all right, notice how this is set up, and you'll have time to copy it all down, but I wanted to make sure you didn't just draw a big old straight line all the way through. In Google, all right, use a smartphone, use your Chromebook, I don't care as long as Mrs. Klein doesn't care, and type in 6 elements of life. We need more than these 6, but these are the major ones, all right? So type into Google 6 elements of life, pause me, and then come back to me. And hopefully you are coming back to me. And what you should have came up with, and we're going to put these down in this table down here so you don't have to write them 2 different times. The first 3 I'm going to write down are, I'm lying to you. The first one is a part of organic chemistry. And anybody that ends up going to college, and if you're in the sciences, it's one of the hardest classes you'll ever take. It wrote my name down. Trust me, I struggled in this class. But it's dealing with the elements that we need to survive. Helium is not in there. Helium, you might think it's less important, and I agree it is. It's not one of those that you absolutely have to have for life, but we need it to make those, so I'm going to put it there. So hydrogen is one of those you should have on your list. We'll just put a little star by it. No pun intended for that. Oxygen, unless you live under a rock, I think we breathe that in. You should have came up with carbon. Okay, we need that one. Carbon, oxygen, and hydrogen. If you really like your carbohydrates, you like your carbs, that's what makes carbohydrates. That's where we get all our energy. So obviously those are essential to our life. Nitrogen. If you're like, hogwash, I want my meat and taters. Well, the meat, protein, has a lot of nitrogen in it. So we need that one. Sulfur. We need it in trace amounts for reactions, chemical reactions that go in our body. Same thing for phosphorus. It's important for bone health, and I could give you a whole health teacher lecture, but I won't. All right, so there's 7 listed here, but helium is an ingredient. All right, so it's not one of the 6 that you should have landed. This dog, I swear she waits till I'm doing these videos and starts barking. The next thing will be for Earl to fly in. But helium, again, is an ingredient. Hold on while I go beat her. Lily Ann, do we have to do this every time? Every time. Come here. Get over here. Get in here. Those people can walk down the street. Alright, so hopefully you've got these written down. Sorry about my swell dog. Alright, so what we're going to do, we're going to worry about the number of protons, the percent of the total universe that are these here in a few minutes. But for right now, for the evidence part, when we talked Big Bang, right, when I shouldn't say we so much, but when you, Mrs. Klein, have been talking Big Bang, within the first 3 minutes, Neil deGrasse Tyson, in one of those videos you watched, it was episode 1, he talked about like that timeline. Within the first 3 minutes after the explosion, protons and neutrons combined into atoms. Okay, and it's funny, we're saying like 13.7 billion years ago. We're up to 13.8 billion years ago, and every time they figure out that Hubble's constant isn't quite right, we keep making it longer and longer ago. So who knows, maybe it was 15 billion years ago, I don't know. But a very long time ago, there was the boom. And when that ejected all those gases and matter and all that, there were all kinds of like just streamed ions almost that streamed out. But it took a while for the protons and neutrons. When I say a while, not too long, but about 3 minutes. And why that's important is the periodic table is arranged by the number of protons. So when we talk heavier elements, it's obviously then not something like, whoops, sorry about that, hung off there. All right, so it's not something like hydrogen, because that